you by thesis123.com. I learn and teach online.
Here's the next question. Number 28. Let x1 of t corresponding to x1 of omega and x2 of t corresponding to x2 of omega be two signals whose Fourier transforms are as shown in the figure below. In the figure, h of t is equal to e power minus 2 mod t, denotes the impulse response. For the system shown, the minimum sampling rate required to sample y of t is the output here, so that y of t can be uniquely reconstructed from its samples is. Okay, so the question gives us 4 options and I didn't have space to write it on this paper, so I have written it down on another sheet. Here are the 4 options: A to B1, 2 into B1 plus B2, 4 into B1 plus B2 and infinity. Now B1 and B2 you will notice are here in the figure, B1 and B2 corresponding to the input signals x1 and x2 of x1 of omega and x2 of omega. Now B1 and B2 are the bandwidths. B1 is the bandwidth of x1 omega and B2 is the bandwidth of x2 omega. And the figure gives us that h of t, this system right here, is e to the power of minus 2 mod t. So correspondingly you will see that the input signals x1 of t and x2 of t making up this system gives out the output of y of t. Now this tells us that the input signal, I will write that here, the input signal is x1 of t into x2 of t. It's a multiplication corresponding to the equation given to us e power minus 2 mod t. We get that from the multiplication of both the signals x1 of t and x2 of t. Now since the question says that we need a minimum sampling rate, when they talk about minimum sampling rate, it is always good to think about the Nyquist principle. Now we'll come to that. Let's look at the bandwidths first. Now if the input signal is x1 of t into x2 of t, then the bandwidth, in order to get the highest frequency component, they are added. Now that is an important point. I'll write that here. Okay, so we have bandwidth of x1 of omega is B1 and the bandwidth of x2 of omega is B2. And we also have that our input signal to the given system is x1 of t into x2 of t. So the bandwidths are added in order to get the highest frequency response. Okay, that's an important point. Bandwidths are added to get the highest frequency response. So this means that the bandwidth would be B1 plus B2. Now this is the general sampling rate, B1 plus B2. But because we are talking about the sampling rate, here the question says the minimum sampling rate required to sample y of t so that y of t can be uniquely reconstructed. Now since it talks about uniquely reconstructed and the minimum sampling rate, we have to remember Nyquist principle of sampling rate. So according to Nyquist principle, let me write that down. According to Nyquist principle, the sampling rate is twice the output bandwidth. So this is the bandwidth of the output B1 plus B2. According to Nyquist principle, the sampling rate is twice the output bandwidth, which means it would be 2 times B1 plus B2. So this expression matches option B. So the minimum sampling rate required in order for the output y of t to be able to be uniquely reconstructed from the samples would be 2 into B1 plus B2. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.